Hi everyone, welcome to the second COALA webinar. I'm Chaofan Wang from TU Delft, and today I will provide you a short introduction regarding COALA project at first. COALA is a European Horizon 2020 project under the topic of the artificial intelligence for manufacturing. It lasts for 36 months from 1st of the October 2020 to the 13th of September 2023. The consortium includes 6 research and technical development institutions and university and 3 solutions provider and 2 innovation management partners. It also includes 3 business partners, including textile factory Pichanda, detergent factory Diversity, and white goods factory Whirlpool. Today, the manufacturing industry is aiming to improve the competitiveness through the with the cutting-edge information and the communication technologies in order to secure a new growth engine. It becomes increasingly apparent to business leaders and that digital transformation is an urgent priority for supply chain and the manufacturing operations that hopes to be more competitive and the resilience. The pandemic further exposed the global supply chain weakness and the industry vulnerableness. And an article in Forbes magazine states COVID-19 has shown that something that manufacturing industries should already know. Traditional supply chain and the manufacturing ecosystem are falling, and we need to shift to more adaptable, agile solutions that are fully digital enabled. Therefore, automation in manufacturing has attracted the increasingly interest of factory managers in which human and the machine will work side by side. Recent technology advances have overcome many traditional limitations of the automation to perform tasks previously thought to be too difficult for machines. Tasks such as picking and packing in regularly spaced objects. Also, sensors enabled within and around machines can optimize the performance for all manufacturing, including monitor, control, and improve the operations with data backend insights and predict equipment for failure and trigger maintenance protocols. Many other technologies like big data and machine learning can also facilitate the factory operations. However, humans still play an important role in manufacturing. 72% of the manufacturing tasks are performed by the humans on the factory floor. Workers' inputs are specifically crucial, and whether it's through the machine maintenance, decision making, or when controlling the operations. However, McKinsey future of work in Europe study predicts that by 2030, Europe will have already lost 13.5 million working age people. Germany, the European manufacturing heartland, will be among the hardest hit with 4 million fewer working age people. Also, skill taught at schools might differ from the job requirement of the specific factory, which require job training and passing the expertise between the factory workers, but how to efficiently provide the working training and pass the useful tested knowledge to new employees are still open questions. Our solution is introducing digital intelligence assistant. Digital intelligence assistant is a computer program that simulates and process human conversation, either written or spoken, allowing human to interact with digital device as if they are communicating with a real person. In factory, digital intelligence assistant could also support or take over time-consuming, stressful, and other unwanted activities, and know and do some things that human associate with intelligence. Here, we introduce COALA. The COALA vision for AI manufacturing is the development of the human-centered digital assistant that provides a proactive approach to support operative situation and characterized by the cognitive load, time pressure, and little or zero tolerance for quality issues. COALA will help shaping the complementarity in the collaboration between the AI-based assistant and the human so that the AI can take over time-consuming and stressful tasks. The human will focus on understanding and problem solving in the complex and knowledge intensive situations. Also, COALA enables on-the-job training to facilitate the factory workers' vocational job training in line with their language, expertise, and needs. COALA also enables research on a human-AI collaboration to improve the competitiveness of the blue-collar workers in managing the AI opportunities, challenges, and the risk in the shop floor. COALA's AI-focused education and the training concepts will prepare the human side of the collaboration by offering the concept for teaching professionals systematically and in the language of the workers about the capability, risks, and the limitation of AI in manufacturing. Here, we summarized our objectives, work paths, output, and outcomes and expected impacts of the COALA projects. Of this, the most important things will be our outcomes. There are two of our outcomes we want to achieve. First is a production line performance improvement and human integration improvements. Also, there are seven parts of the expect impacts include agile production process and improve quality production and process. And the second one will be optimal complementarity of human and AI. And the third one will be create growth and impulses for augmented manufacturing analysis. And the fourth one will be support the adoption of trustworthy AI. The fifth one will be increase societal resilience, and the sixth one will be the support digital innovation hubs service offers, and the last one will be create a new service for the professional education and the training sector. COALA involves the three business partners, including the white good production company, Whirlpool, where the COALA could help with first adopt a productive quality strategy links the quality control of the finished product with design stage and shop floor. And the third one, which will be reconfigure its production line and the facility root cause analysis. In our previous webinar, we have discussed about the Whirlpool cases. If you are interested, please visit our YouTube channel or website. Also, COALA involves the detergent production company, Diversity, where COALA is to increase the efficacy of production and reduce change over time and capture the best practice and transferring them between the manufacturing lines and T-state line managed knowledge capturing and formalizing and transfer to the co-workers. The webinar will focus on the diverse case in the next few minutes. And in our third webinar, we will show the p-chance cases, but it will not cover by this webinar. So, as I mentioned above, the COALA facilitates augmented analysis and on-the-job training. In the following slides, I will provide more details. Regarding the example of functionalities of augmented analysis, the COALA Cognitive Advisor collects and analyzes data from the shop floor, and the user monitors analysis through the dialectic interactions, and the COALA Cognitive Advisor could explain the recommendation to improve the trustness and achieve transparency. And the last one, which will be context-aware features, streamline interactions. For example, a factory manager would like to know the prediction of a machine fuel consumption for the next 15 days by talking with COALA Cognitive Advisor. COALA Cognitive Advisor first extracts the intent of the people who initialize the conversation by recognizing the intent of the forecast. The COALA Cognitive Advisor could retrieve the information from a graph database, and by fitting the retrieved machine data and shop floor data into prediction module, COALA Cognitive Advisor could then provide a predict result to help the manager to understand the machine status. Regarding the on-job training, the operator shares the knowledge through the dialectic interactions with the cognitive advisor. The operator receives the advice based on their expertise. The cognitive advising behavior adopts to the learning progress. Alternatively, the cognitive advisor identities and instills the best practice. On-the-job training also involves 3 different functionalities, including novice asking the instructors, break down the tasks into small steps, and also sharing the knowledge with the assistant and providing the learning nuggets. Also, but better to design the COALA Cognitive Advisor, we have 3 design aspects that need to be carefully considered. The first one, which will be how to deploy COALA in the manufacturing settings. Cognitive Advisor could have different forms according to different interacting methods, including screen interaction, voice-based interaction, and their combinations. However, the factory settings are always noisy, and the production machine could even generate more than 100 dB noise, and resulting the voice-only interactive method is impractical in factories. So we designed COALA as a text-based cognitive assistant to make it easy to use in manufacturing settings. Also, there are unexplored questions about applied AI ethics. The first influence factor includes the balance of the power, loss of the autonomy, and bias in training data. We need to practice ethics by design, but delegation treats autonomy for free time, but the workforce in the factory contains bias as well. Moreover, more issues could pop up, like what if the operators uncrucially follow the recommendation of the cognitive advisor, and what if the cognitive advisor suggests a task that could harm the users, and also what if the cognitive advisor recommends a procedure that could damage the equipment, or some example could be who owns knowledge generates discovered with the cognitive advisor. Apart from this, privacy also affects factory workers' attitude towards COALA Cognitive Advisor. The influence factors include general data protection regulation, worker council and the worker union, and also the labor laws. Okay, and of course we need to practice privacy by design, but personalized functions requires knowing the personal data, but the customized assistant require knowing users' pseudonyms, and also the restriction assistant to assistant like to require operator to register assist with systems. And also some questions will pop up, like what if the username call workers in the conversation with assistant, and what if the employers use the cognitive advisor to check the operator on the shop floor? But to address the design questions mentioned above, we need to have a functional COALA Cognitive Advisor and use the prototype to help the factory workers and managers to better understand what COALA can do and help us to better shape COALA. Here is our system overview for COALA prototype, which includes 6 modules. Namely, which will be natural language processing unit and the dialogue management layer and the AI reasoning and planning layer, and also the COALA mobile platform, COALA dashboard, and also the system and the data security layer, also about the data collection and maintenance layer, and the last one, which will be manufacturing resource layer. And thank you. Here, I will pass the presentation to the Barnabas about the COALA in detergent factory diversity.